As you know, Leonardo is an international society for art, sciences, and technology. And the laser talks are part of this network of people working in the intersection of art, science, and technology. And specifically, the laser is a program for these evening gatherings, this evening in Hong Kong right now, that bring artists and scientists together for these informal presentations and conversations. And what we want to achieve is having a platform for people to meet, for conversations to flow, and we would like ideas to sprout and collaborations to germinate. So if you see fit, please try to get in touch with other people in this room, and let's try to find connections with people that are interested in the same topics or that we could be working with. So this is the main goal for tonight, is for us to have new ideas, new forms of thinking, and also to establish connections and collaborations. We are normally hosting the laser with Dr. Jun Lam, myself. My name is Mariana Perez Bobadilla. I should have introduced myself since the beginning. Known online as an artist as Maro Pebo. And we also work with Wong Kit Ji in Hong Kong organizing this event. Today, I'm very happy and very honored to present Absence, Presence, Belonging, and Becoming, Cells and Bodies in Art and Anatomy. Where we'll be having Dr. Nina Sellars and Dr. Yun Lam, as I said, making their presentations. And then we'll be open for questions. Guys, I would like to ask everyone to mute themselves while the presentations are going on. And then if you want to ask a question or anything, you can unmute yourself anytime. Just, I'm gonna mute everyone and then unmute. Okay, sorry. And then, there you go. Jessie French just joined us. So without further ado, I would like to introduce Dr. Nina Sellars. She is curator at the Harry Brooks Allen Museum at the University of Melbourne, and she is a visiting research fellow at the Museum of Applied Arts and Sciences in Sydney, Australia. She has been artist in residence at Symbiotica in Perth and research fellow at the Alternate Anatomies Lab of Robotics and Art Research Group in Curtin University in Perth. She has presented her work in different venues, including the Museum of Contemporary Art in Sydney, the Perth Institute of Contemporary Arts, the Anna Lenowens Gallery in Halifax, and soon in the RSU Anatomy Museum in Riga in Latvia. Her recent author publications have been incredibly successful. This one is very recommended. I would, everyone that is interested in this talk, I would very much recommend you to look into these publications. Includes Fat Matters, Fluid Interventions in Anatomy, and Robert Hooke's Micrographia, a historical guide to navigating contemporary images. So I very much encourage you to look for these publications.
Okay. So we're good? Okay. Well, it's a pleasure to be presenting for the Hong Kong Leonardo Laser Talks and to be doing so with Professor Lam. So I thank the organizers sincerely for the invitation, in particular Mara Pibo and her very, very kind introduction. So thank you very, very much. And since here for me, I'm in Melbourne, Australia, I'd like to acknowledge that I'm on the traditional lands of the Wurundjeri people of the Kulin Nation, and I pay my respects to the elders past, present, and emerging. So tonight, I'm going to be focusing on just one of my artworks and provide a little bit of context for its making and also give some background to my arts practice. So for the last 25 years, I think everything I've done has been connected to anatomy. And when I speak of anatomy, I'm not meaning so much the body per se. I'm referring more to the discipline of anatomy. So I'm really interested in the history the methods, the foundational ideas that go to supporting this way of constructing knowledge about the body. And the reason why I think it's so important is that anatomy has really come to define what the 21st century body is. And I think as it feeds into conversations about posthumanism and transhumanism, ideas about subjectivity, identity, it's really important to recognize that anatomy isn't a synonymous term for body. It's actually a knowledge construct. It's a way of engaging with the body. But we often treat these terms as being synonymous, so body and anatomy. And if we do that, we're incorporating all these sorts of ideas that connect to anatomy into naturalizing them into our identity. So the work I'm going to be speaking about is a piece called Sentinels. And Sentinels was a biological art installation that was made predominantly at Symbiotica at UWA. And it was made for an exhibition called HyperPrometheus, The Legacy of Frankenstein. And this was shown at the Perth Institute of Contemporary Arts. And it was held as a commemoration or celebration of the publication, or the bicentenary of the publication of Mary Shelley's Frankenstein. So what you can see in the image is it's a documentation of the installation. It had its own sort of side alcove gallery off the main hall. So you could approach it from a distance and you could see it as you were getting close to the work. And as I so often do, the physical components of my artworks tend to be small, but the images, the projections of the work tend to be quite large. And I've done it again with this piece. And what you can actually see, the small little glowing object in the middle is an incubator. And inside the incubator is a bioreactor. And the bioreactor contains a very small replica kouros. And the kouros figures originated in ancient Greece. They're statuary that were used as dedications to the gods, but also as sentinels for the dead in burial sites. So carers for the dead. So the two images on either side are actually live feed video projections of elements that are inside the incubator. So this kouros that you can see that's on the left-hand side is actually only about 3.5 centimeters tall. It's made of hydrogel, and inside it's supporting living human preadipocyte cells. So when I say preadipocytes, it's basically human fat tissue that's living and growing in the gallery space inside this kouros figure. And I'll show you some of the animation later that shows what the image video feed's actually showing to the gallery visitors, because the figure was being drip fed. So at set intervals, a drop falls onto the top of the head of the figure and it traverses down the figure. And this is actually feeding the figure nutrient. So the figure is alive. It's being supported by the incubator with CO2 warmth, because it's human cells. The incubator is sustained at 37 degrees, and nutrients that are feeding the cells. And the projection that's on the right-hand side is of the vial. So the vial itself is only about 3.5 centimeters tall. And this vial was the original cell vial that I purchased from a tissue bank in America. And seductively, the label reads, it has the code number, but it reads primary subcutaneous normal human. And it has the lot number and the instruction to store it at minus 130 degrees Celsius. So what I was trying to do with this work was, in a way, to question anatomy and to make clear that anatomy had an invention period. So it sort of arrived around the 4th century BCE. And the Kurai figures were around a century earlier. So in a way, I chose the kouros figure because it existed prior to anatomy. And what I'm sort of suggesting with the work, with almost the matching sentinel on the other side, the cell vial, is a provocation to think that perhaps we're heading towards a period of post-anatomy, where there's more fluid conceptions of the body. Anatomy has very clear classifications and boundaries, and in a way, these are being contested in the 21st century. So why do I choose to work with fat? I've used many mediums in my arts practice, and I still traverse all these different mediums, from drawing to photography to installation to light installation to tissue culture. I find that each medium has a certain way of questioning. It's a way of interrogating anatomy. So tissue culture was a perfect way of addressing the questions that I had in this circumstance. And I work with fat a lot in the last 6 years, imaging fat or working with fat as an actual material, because it doesn't really appear in the history of anatomy. So we have the origins of anatomy in ancient Greece, but we have in modern anatomy really appears with imaging in the 16th century. And from that period on, we don't really see fat in the images. And the reason why this is problematic is that anatomy is a science predominantly based on visual observation. And for the circulation of its knowledge, it's reliant on images. So to not appear in the archives, it's a very strange occurrence for something that's so important. And it is now being recognized as something that's very important in the 21st century. So fat is actually the most contested, circulated, and instrumentalized part of the body in our era, but it doesn't occur or doesn't appear in our history of anatomy. And I work in a medical school, and I used to be an illustrator, and I'm kind of aware that a lot of the images that we use haven't really moved on from a method of seeing that from the 16th century. So the images that I have on screen, this is Gray's anatomy. This is mid-19th century. But Gray's anatomy is still being used. I mean, I think we're up to about the 41st, 42nd edition of Gray's anatomy. But as you can see from these images, there's no fat in these images. And in a way, fat defines anatomy by antithesis. What I mean is that fat tends to be the thing that you remove in the act of revealing anatomy. And where this gets problematic is that fat was reclassified as an organ in the 1990s. And in the 21st century, at the turn of this century, it was discovered to have more pluripotent stem cells than bone marrow. It has about 400 times more pluripotent stem cells, and it's very easy to harvest. So we see it being used a lot in regenerative medicine, but we also see it in context of research where it's seen as a negative thing. It has multiple definitions that all exist simultaneously, and in effect should be cancelling each other out. So it's classified as being structural and non-structural, a bad thing and a good thing. And in a way, what I really like are these debates. I love the fact that fat cannot be pinned down very easily within the classifications of anatomy. So in a way, it's a very useful thing to be able to turn around and use fat as almost a critical tool of investigation to question anatomy. This is just one of my favorite images from the 16th century. And partly, I used to work as a body dissector. So part of this is that I love the simplicity of the act that they seem to be showing here, that you remove skin, this sort of the social barrier between the body and the world. And all of a sudden, we're located on the muscles. There's been nothing in between. And the image on the right is just to show it's a frame from the Visible Human Project. And I've removed all the organs. And what you can see that's remaining is what you'd actually see in a cross section of the body with all the fat that surrounds the organs. Every nerve, every vessel is embedded in fat, but we don't get to really see or appreciate that. Okay, provided this both for the text, which describes my interest, but also I've lifted a line from one of my favorite writers, working with Sarah Kemba. It's taken slightly out of context. It's a book on media theory and talking about technology and our becoming with technology, but it beautifully translates into my thinking of anatomy. So anatomy literally means to cut the body asunder. So it's an action. And whether that cut, it has a dual meaning in a way. It's the physical cut of dissection, but it's also the visual cut of image making. And so this realization that an incision is also a decision. And it entails an ethical imperative. So when you make a cut into the body, what you decide is anatomy and what is not anatomy, it's really important to question what informed that cut, that decision. And then in a way, I'm sort of making the call that we should be to sort of cut and to cut better in the future, in a way, to consider what we're doing when we define body, especially if we take notions of anatomy into ideas of transhumanism and things like that. So yeah, so fat is one of those things that really doesn't come to the forefront in anatomy, but it's one of the key things that defines anatomy. So I realized this morning that actually the photo on the right is from almost 20 years ago when I was working at UWA as a body dissector. And it's quite poetic that I returned to work at Symbiotica, which is a few stories up from the dissection lab where I used to work. And my job as a body dissector, as I sort of suggested, is to remove fat from the body. That's how you spend your day, to reveal anatomy. And it's treated as a biological waste. It's not considered part of the body in that sort of study. So I go upstairs in 2016 to 2018, and where I spend my days trying to care and grow fat cells. And in a way, I feel like it's kind of like a penance for all the years that I was erasing fat from the history of anatomy, both as an anatomical illustrator, but also as a body dissector. So just to go back to the making of Sentinels, because there was a beautiful parallel story that was happening at the same time. So in 2018, I was making the work in the labs, and I decided to use a 3D downloadable file from Thingiverse of the Getty Museum's kouros, because it's one of the most beautiful kouroses, kourai. And but the thing about this kouros is there's been a debate for many, many years whether it was a forgery or not. And it was decided in 2018 that it was indeed a forgery after paying $9 million for it a few decades earlier, and it was removed. You can't see this kouros anymore. So while I was making real copies, the original forgery had disappeared from view. And the beautiful thing about this forgery is that normally a forgery becomes apparent to an expert because of a lack, in a way, or a clumsiness in the skill. But the rumors about it being a forgery in a lot of ways came about because of its perfection, this sort of utopian Frankensteinian sort of figure. It was too many perfect stylized bits from a broader period brought together into one figure. So its perfection was announcing that it was a forgery rather than a lack. And the figure on the right is one of the many test figures that went into making Sentinels. So after deciding to use hydrogel to make this figure, I had to figure out how to make hydrogel stand vertical and support the cells. So there was a lot of testing, and I have a lot of thanks for one of the people that was assisting me with this was Mike Bianco, who was my lab partner at the time. So this is just to show you the diagram of how the cameras were looped up. So I had the cameras on the outside of the incubator, and they were feeding back to two projectors that were on the rear side of the gallery wall. And it also gives me an opportunity to show you the drip feed. So it was not happening as fast as I have here on the loop, but one of the things that I found making a biological artwork with tissue culture is you've put a lot of energy into having a living artwork on display, but how to evoke the sense of life when you're working with something that's invisible. So life itself, the human cells that were living in this figure weren't visible to the naked eye, to the gallery visitor. So in a way, the wetness and the movement of the drip is what evoked a sense of life. And for me, I particularly like as it runs down the outside of the legs, it's almost this like electric shock version of light that comes down with it. Just going to speak over a bit of video to give you an idea of some of the things that went into making this work. So the cells, after I had cultured them, were stored in liquid nitrogen, -80 degrees. And so every time that I needed to access cells, I had to get them from the liquid nitrogen. And in the making of this, you should hopefully see soon, I had to make a 3D print of the figure, and that was, we made a Silagard mold for it. So this is a mold that was used to create the figure that you see in the gallery. And so I made a small stand on the figure with a magnet in the base. So underneath the flask, there's actually a metal plate that makes the figure stand upright. But this was the mold that originally it was cast in. And so the hydrogel has to be cured in a UV light box. So this is just inside the Symbiotica lamp. And Nathan Thompson is the builder of the incubator. So the incubator itself wasn't very large. It's about 40 centimeters tall, but this is in the workshop with Nathan. So you'll see my face in a moment where I look kind of thoughtful and reflective, but really it's kind of an annoyance when I realized that I had actually made an invisible artwork. So it was a transparent artwork that once submerged in nutrient became completely invisible. So that's partly the reason why it's drip fed, because yeah, you couldn't see what I had actually made. So that's part of the reason for its display. And this is just the install. The install was only meant to be a 20-minute drive. After going from the lab up to the gallery, it took 2 hours because, of course, I realized that with every vibration, the figure was going to be able to break. And this is opening night. So you get a sense of the size of the install. So the work was allowed to actually die in the gallery. Nutrient was not supplied after a period, and he beautifully desiccated. He sort of dried up and basically just became a little tiny fragment of a being within the installation. Okay. I'll show you a couple of more things, but this is just an acknowledgement and a realization of how many people go into making a biological artwork. It's like a village that's required to raise a problematic child. There was a lot of assistance in making this work. So this is just an acknowledgement of those people, and many thanks to them all. So I'll just quickly show you an iteration of the work. So this was a digital iteration of the work that went on show in Halifax in Canada. So the work was shown in a mall it's like a film that you put onto a gallery external window. It's a rear projection film. So it just cycled through, it showed the drip fed figure. Then it also then suddenly blasted into the cells. So it gave me an opportunity to actually show the footage of the cells growing that I'd done, that I had made of this in the lab. So a time lapse video. And then it just cycles on into the vial, and it just kept on looping. And the part of the thing that I really liked about this is when you show a work in a mall, it's got a 24/7 viewing. So from people at 3 o'clock in the afternoon coming home from school to people coming out of a pub. So this was a second life of the work. I might just, since I have a minute, just very briefly relate to earlier work. Between being a body dissector and coming back to Symbiotica, I did my PhD on the history of light and anatomy. So I was looking at how light impacted our understanding of the body. So from Renaissance lit anatomy, candlelit anatomy, sorry, in the Renaissance, to things like X-ray and CT and MRI in later centuries, where light is actually being penetrated into the body to create images, and how that affected our perception of the body. And I became very interested in volumes without mass, and this idea of transparency being a valid way of understanding the body. And I'll just very quickly show you this work. So this is Lumen. Oh no, this is Lucida. So Lumen was my prototype. Lucida was the final work. It's 9 centimeter square sheet glass that look transparent, but they actually have micro fractures in them. And I was trying to create a work that made volumes without mass. And it's a kinetic work. These are just stills. So the images, again, as I did with Sentinels, I have very small physical components, but the images are quite large. So the light for this was a plasma arc fed through optic fiber cables. And they created these really, really beautiful images that are completely sharp and in focus because it's a pinpoint source of light, but they're very, very bright as well. And I'll just end with this video of the piece. So this is the installation with the lights on. So down the very end on the right-hand side is a plasma arc that's located in a closed sealed box, and optic fiber cables connect it to the installation. And I made this work with my brother, very generous in the labs. And the noise that you can hear is the amount of fans that I needed to keep the work, to keep the light cool. So I think I'll just end it there, Mariana.
Thank you. Wonderful, Dr.
Like a mad run through my artwork.
Beautiful, beautiful, Nina. Thank you so much, Dr. Nina Sellars. I had never seen this work. I think it's great. Thank you so much for this insight and a better way to understand your work. I think many of us have seen it before, but it was great to be able to understand what's behind it and also to see you working in the lab. That was also beautiful. To understand all that it entails, as you say, the huge team that is behind making this kind of projects possible. You know, for me, it's very relieving to understand that it is necessary to have so many people working to make it something like this possible. So if anyone has questions for Dr. Sellars, you can write them in the chat. We are going to continue with the second presentation of the night, second and last presentation of the night, which is Dr. Jun Lam. And if you would allow me, I would like to introduce Dr. Lam. I'm going to ask him to unmute. Okay, you're unmuted. Dr. Jun Lam is a biochemist and cell biologist. He was a postdoctoral researcher in the Wellcome Trust Biocentre in Scotland, and he's now an associate professor at City University of Hong Kong, where I met him as my professor. He has published over 100 scientific papers and patents, and is the current leader of the Global Research Enrichment and Technopreneurship Program at City University of Hong Kong. He has been a scientist in residence in Symbiotica. And I'm missing one slide where I explained, and let me try to find it. Because Dr. Lam, we're really thankful because he has been collaborator with many artworks, including Wonky G's Magic Wands, Pythons, and DNA Splicers, and Art Basel Hong Kong. And he's now working in a collaboration with Ken Rinaldo for CRISPR-Seed Resurrection. And he has also participated with me in the production of Microbial Emancipation last year. June is also a co-organizer of this event, of the Leonardo Art and Science Evening Rendezvous, and of course of Café Scientifique in Hong Kong. So without further ado, I would love to invite Dr. Lam to present his research and his great ideas on anatomy, bodies, and cells.
Thank you very much, Mauro. It's really a great honor to present tonight and after Nina's great talk. I was really touched by her artwork, so I'm a little bit emotional. So basically, I'm not very able to speak, to be honest. So I'm going to try. So, oh, why am I? And am I sharing my screen?
You are.
I'm sharing my screen, right?
Yes.
So let's see how it goes. So basically, I'm a scientist, but this is kind of my kind of standard self-introduction slides. I like to call myself a professor of ignorance because basically I just don't know anything very much. But on this self-introduction slide, I put art and science is my #1 project, right? Because it's been my really my obsession and interest for a number of years now. And when I heard that Nina was invited to give a talk tonight at Laser Hong Kong, I really, I never done that, but I really begged Mauro to give me a chance of co-presenting with Nina, because not only because I really like Nina's work and I've been following and stalking her for a number of years, but also I really want to have a chance of being a co-organizer of LASER, to kind of give you, many of you who are distinguished science artists, scientists, I really like to have a chance to talk to you tonight about how a scientist responds to an artwork. So the legend have it that I was actually in Perth when Nina's artwork Sentinel was premiered. I was actually there when kind of you show one of the videos of the opening. I was actually there in the audience, and I immediately texted Mauro, telling her that that's really a great work. And I was at that time, I think it was 2018, 3 years ago. I really didn't know too much about art. I've been an art lover, but I really didn't know anything about art. So, but this particular work, because it was for reasons that I'm going to tell you later, is really touched to the core of my heart, because there's something that is related to my career. So, what I'm going to tell you a little bit tonight is some of the work that have been going on in my lab after I've seen this work. So in a way, a lot of art science talks about science and art, usually not always about how the artist got inspired doing his or her visit to a science lab. But what I'm going to tell you is a different take about a scientist being inspired by an artwork and use my science to respond to this art. Is it okay? So also I tend to speak too much. So Mauro is going to, Mauro, you authorized to stop me for the past like 20 or 30 years, I've been a cell biologist, right? So this is what I do. So basically, my career has been about growing cells in the lab. The cells are either grown, so basically these are kind of snapshots of videos made by various people in my lab. And usually the cells are cultured on a plastic dish, right? Kind of flat plastic surface, or in 3D, right? So the second one is basically cells in hydrogel that are is a microscopy version of what Nina showed you, right? Cells trapped into a gel, and then the bottom panels are basically engineered surface, right? So basically we trick the cells by exposing the cells into these regular surfaces, right? So for no particular reason than to just publish a few papers and pretend to kind of discover something about cells. And but after seeing Nina's work, I've been increasingly interested in not only the cells, but the kind of the surrounding of the cells, especially the visuals that we scientists or biotechnologists are using to hold the cells, right? So basically, the tech is basically these cells that I just showed you in the past slide. They used to belong to the body of living organisms, right? But then they're taken out of the body. The organisms are dead, right? And the cells are somehow kept alive by technology, right? By putting into a dish or a flask, or and these are the flasks, right? So I've been very interested in the industrial design of lab equipments, and nothing is more interesting than the tissue culture flasks, right? So basically, this is actually from a website where we order our flasks, right? So Corning is a kind of a biotech company that make a lot of these tissue culture equipments. So they basically, for about 200 euros per case, I think it's a case of, I think 200, you can buy these flasks, right? So if you read the description, the flasks are designed with advances, for example, round shoulders, and it's easy to grip, right? And then the design is basically for the lab users, for the scientists to hold the flask in one hand so that he or she can open the lid, right? In one hand, because you have to, the other hands have to use to pipette the cells, right? So, but if you read these kind of passages, right, it's basically an ad, right? You kind of start to notice, I started to notice that this description or attraction or the design of the flask is all about the scientist. It's all about the person who's doing the tissue culture. It's nothing about the cells, right? As if we kind of no longer care about the cells that are now taken away from the original organism, the body, and put into this flask. And nobody asks the cells whether they like it or not, right? So, and as a scientist, or I'm sure Nina will agree as an anatomist, that the cells inside the body is very, very different from the cells that are being cultured in this plastic flask. So this kind of from a scientific paper, and basically this is what we know about the cells, not in the flask, but in the body, right? So basically they're trapped in a network of kind of proteins and sugar called extracellular matrix, and they're not lying on a flat synthetic surface, but they are really embedded, if you like, in a messy network of things, right? So, and we are kind of starting to look into this idea, right? So if you kind of think about the body before the cells are kind of removed and put into a plastic surface, the body really look like that, right? Kind of in a microscopy scale dimension. So this is actually a piece of a bone, which is called the growth plate, right? So basically is where the two ends of the bones where the growing occurs. So basically, this is the bone, and this kind of a longitudinal look, right? So, but then we can also use a knife and cut the bones kind of in this way, right? And this kind of it becomes very, very interesting, right? It's very, very intriguing to look at. So it's very, very complex, and it looks as if they are like an environment, or almost like the cells are being housed in this environments, right? So we like to look at this section as if we are opening the body like a book. So basically, these are the pages we are kind of looking at through these bones, right? So what we decided to do, therefore, is to take a piece of tissue, kind of anatomy, and then cut it, opening like a book, and ask the cells to kind of to touch this book, right, to see whether the cells can make sense of this very, very intriguing environment. So And we quickly found that, so basically these are the cells, right? The same cells, the same kind of cells that look identical when cultured on a plastic dish, right? And if you took these cells and put on different tissues, so there's a bone, there's a cartilage, and there's a tendon, the same cells will very, very quickly, I mean very, very quickly, within minutes, adopt a different shape. So, so basically they're responding to this environment, right? So, and this is how the cells look like, right? So this is a piece of tendon, right? And the red are basically pseudo-colored mesenchymal stem cells, right? And some of these cells are actually from fat, right? So they call adipose mesenchymal stem cell. You can take these cells from bone marrow, from fat, and also, as we show you later, also from umbilical cord of a baby. So now we have a new kind of petri dish, right? These are no longer cold and synthetic and human-made material, but it's actually confronting the cells with a body. So, and we also want to play tricks to the cells, right? So this is something that we did, and so basically there's a tendon, right? So if you cut the tendon in this way, the kind of the texture look like that, right? But then if you this is using Chinese toothpicks to illustrate this point, and if you cut the tendon like that, then the environment is totally different, right? So the question we ask is now, if you show the cells these two different kinds of environment that are prepared from the same block of tissue, what do they look? What do they see and feel? So and we can see that they look totally different, right? So basically, this is longitudinal section of the tendon, and these are the cells, right? These are the cells, and these are the same cells, also mesenchymal stem cells. But then, if they're confronted with a body that is cut in different ways, the cells already can tell the difference, right? So, and then this is really what is inspired by Nina's work. So now Nina can actually make a replica of this, how do you pronounce it, kouros, this sculpture, right? So how about we also do that, the same thing, right? But instead of making a replica of a human artifact that kind of celebrate historically the body, how about making a replica of the tissue? So so we actually do that. So we actually make a plastic replica of the tendon. So, and this is kind of a microscopy replica, right? So this how the real thing look like, and this is the replica how it look like, right? And we are now therefore, and then we expose to the cells either the real thing and the replica, right? I don't have time to go into this kind of scientific thing, and it's quite boring anyway. But then the cells actually can respond to both the real tissue and the replica in a very, very similar way, and we can actually detect and quantify their response. So, and then we decided, how about we take it one step further, right? So we're now talking about taking a body, a real body, and then make a replica of the body, just like making a sculpture copying the body, right? But then the sculpture or the marble sculpture is no longer the real body, but sometimes it also can evoke human emotional response, right? So we decided to do it one step further, and this is to do with this kind of petrification process that are in our legend, in human legends. So to cut a long story short, we have a kind of, we develop a technique that will fossilize a tissue. So usually kind of fossilization is basically is a term that means turning organic body into an inorganic kind of form, usually stones, right? So it usually take like several thousands of years, sometimes even longer. But using chemistry, we can actually speed up the process. So this is actually a worm, planaria, that we are also doing, using it to study regeneration in other projects in my lab. But we can actually fossilize this worm. Instead of in thousands and millions of years, it kind of take a few days, right? And it's a really faithful replication of the body. So if you use electron microscope to look at this fossilized worm, you can actually still see the hair of the worm, and the hair, of course, is how the worm moves, right? Core on the surface, and we kind of can do that. So basically, this is a real tissue. By the way, these kind of images, black and white image, are called scanning electron microscopy, which allow us to see something, or the shape and contours of something in really great details, right? So for example, this ruler is like 20 micrometer, right? 1 micrometer is 1 million of a meter. So this is a real thing, and this is the replica. So by the way, this replica is made in silica, which is the same composition of glass. So basically, we're turning a piece of meat into glass. But you can see how accurate the replication of the structure is, right? So it's a tendon, spinal cord, and cartilage and muscle. So by the way, these are not human organs, right? They're all from cows. Basically, we got these organs from a supermarket, food market. We can also fossilize bacteria. So this specially dedicated to marrow. And this one is dedicated to Nina. So we can actually fossilize a piece of fat. And this is, of course, the scanning EM image of the fat, right? So now, here's the kind of one of the final slides, right? I don't want to take too much time. But this is actually what is the title of tonight's talk is all about: absence, presence. So what our lab is really interested and obsessed with is when you kind of attempt to grow cells, this kind of, for example, stem cells, but we can also do that for cancer cells, on a dish. We're actually taking the cells from kind of a dead animal, right? And then try to keep these cells alive in an artificial environment with a kind of precisely formulated medium and a plastic dish, right? What we want to understand is, in this process, we are keeping the cells alive, but exactly what information have we removed from the cells? Have we taken away from the cells? So, and what we want to do is, by this kind of fossilization, replication process, try to give back this missing information. And by learning what is missing and what is given back, whether the cells are completely behaving in a completely same ways as the cells in the body, which is impossible, right? Or by doing this kind of approximation, we try to learn what is the body? What is the body doing to the cells? So belonging and becoming, to me, as a scientist, it means that the information that is originally belonging to the body, and how can we decode this information? As a scientist, there's kind of scientific reasons for that, because by giving this missing information of the body to the cell, we will improve the way that we culture the cells so that it becomes a more accurate representation of life, so that we can kind of, for example, build a better models for stem cells and cancer, for developing drugs in a more accurate ways. But what we really want is to close the loop between culturing the cells and kind of giving and giving the cells the body. Becoming, meaning we are working on stem cells, and we really want to know what becomes to the cell, what the cells becomes after they're exposed to this body informations. So, and kind of know they have done this before, and the kind of in the next few slides, the kind of the answer to this becoming question is really, really shocking. So for example, if we take the cells, mesenchymal stem cells, the kind of cells that these are actually from umbilical cord of a baby. And if you culture the cells on a kind of a plastic dish, the cells is kind of doing nothing, right? But if you take these cells and put it in a kind of a more kind of body-like pressure dish, if you like, which is actually this fossilized tendon, the cells will kind of change the shape, right? As I told you, within minutes. But what is even more shocking is these cells, without any growth factors or kind of hormones, these cells will become attendant cells, right? Meaning that this shape or this fossil is actually informing the cells to become the cell type that are originally from these tissues. So, so this is another kind of experiment, right? So this is actually a fossilized surface, not of tendon, but of a spinal cord, right? So you can see that these are the same cells, right? Also mesenchymal stem cells, and this is actually this one. Unfortunately, I'm kind of probably maybe I will show it to cursor. I don't know whether you can see my cursor, but this on the right side of the slide is actually this fossilized spinal cord. On the right side is actually the slide, right? Basically, the cells are on the slide are basically on the kind of grow as a layer of cells, but the cells that are on the spinal cord fossil, they're not able to stick anymore, but they kind of grow into a ball, right? And if you take the cells from this ball and kind of put it in another environment, another dish, they become neurons. So meaning that this kind of this glass that are kind of in a way engraved in with the shape of a spinal cord is actually giving an instruction to the cells to become the cells that are in the spinal cords, right? Without any additional chemical stimulation. So this is really my last slide, right? So just to kind of look back at kind of the reason that we are doing all this experiment. So I learned from Oren Katz and Yona Tsu, who did another one of my favorite artwork called Victimless Leather, in which they grow the cells into hydrogel jacket. Is this jacket or this kind of environment that is enveloping these cells can be called an extended body. And what they said is a amalgamation of human phenotype and tissue. But even more, it is actually a body that is survived only by technological means. It is also a device that draws our attention to the need of re-examining the current taxonomy and hierarchical perception of life. So I hope this kind of short talk can give you an idea about what we are doing. This kind of fossilization project is still going on. I'm happy to tell you a little bit more about it, but in conclusion, what I would like to say is artists are not just making beautiful and meaningful work inspired by science. While you guys are doing this work, scientists are also watching and got inspired by you guys, not you guys, but inspired by artists and transforming their work. So I hope this is kind of okay. So this all I have. I think this is my last slide. Yeah. So thank you very much for your attention.
Thank you, Dr. Lam. That's great. Thank you so much for translating such a difficult, such a complex process that you're carrying out for the cells into something that we could understand in terms of fossilization, in terms of the medusa. So we could also get familiar of the process of becoming of the cells and how the cells recognize the surfaces and become different kinds of tissue. I think I still find that fascinating, and it's still a little bit hard to follow, to understand, but thank you for your translation. If anyone has questions, you're welcome to pose your questions right now. We have already a question here. It's open for both Nina and Dr. Lam and Dr. June. And it says, as it reads, sometimes when artists and scientists engage in these collaborative projects, they come to it with very heterogeneous expectations and ideas about the other side. Can you talk about these expectations of your work, competences, or possible contributions that you have experienced from scientists and artists when collaborating with them? And I think it's also interesting for me to understand the work of Nina as an artist and also as a scientist. So she can like literally give us both perspectives on the collaboration.
Would you like me to respond first?
If you feel for it, sure.
Yeah. I suppose I always position myself as an artist. I end up working in dissection labs and medical schools, but I see myself as an artist. In regard to collaboration, it's interesting. Each one is so different when you come to a collaboration. I mean, in a way, the work that I did with Sentinels was over a number of years and a number of conversations with different groups. And so, for example, an artist taught me tissue culture. That was Yunat Zer. And then, of course, I collaborate with my brother on the second work. So, yeah, I still very much position myself as an artist, and I come at each collaboration in an organic manner. I never find that when I'm just partnered with a scientist, I just feel like I'm awkwardly sitting and staring at someone. It tends to be like almost an attraction and sort of social connection first. So.
All right. June, do you want to say something about your process working with artists?
I guess the question is about expectations and from both sides. So Mauro, you know me very well. I kind of love to talk to artists, right? So, but I think we discussed before, and I remember once you said you're going to be an artist, and I never said. I told you I will never be an artist. So I'm a scientist who my creativity is channeled through my science. So so I'm kind of not interested in making the artwork and not, but so basically science and scientists and artists create through the different channels, and let me organize a little bit. Whenever we collaborated with an artist, a lot of scientists, when they collaborate with artists, they will become very quickly impatient, because of course we talk in a different language, right? Scientists are very specific, and we are very in a way target oriented, but then artists are process oriented. So I think we have to understand that mutual respect is very important. Sometimes a lot of artists will like to come to the lab and do a few experiments, right? But then they quickly realize that these experiments are technically very demanding, and they become very quickly impatient. So, but then so for example, the kind of experiment that I just showed you is kind of not, it will probably take a few years of experience to design this kind of experiments. So I think the important thing is to start from a concept or an idea, and then we will take this concept, and then we can actually We don't probably need to stay in the same room for a long time, but each party can take the same concept and then do different things, right? And I think the world need this kind of inspiration. So I don't know, I'm kind of a little bit disorganized, but I may come back, right? So
yes, I think we can come back to this idea of like the process of collaboration, which are not always granted. We have a few more questions about this topic, but I would like to, we can go back to it in a moment. But I think there's this very interesting question that I would like to pose to you guys from Annette Manning. Thank you very much for your question. And she asks, she's an artist working on care. And she asks, how either of you understand the concept of care in your work? And working with cell culture, there is an extreme notion of care because like these animal cells are so fragile and so hard to keep alive, right? So have you ever thought about the notion of care within the way that you work?
Yeah. So from speaking from my perspective, I feel like I care a lot in general, and it's probably why I end up making a lot of my artwork. I care about concepts of the body. I care about how people are perceived. And I know I cared a lot about my tissue culture. It was actually really surprising. Like there was one time where I ended up walking around Perth at about 6 a.m. in the morning crying because I thought I had done something that had actually had left some of my tissue culture to perhaps be dying. So I had to wait an hour or two to check whether it was actually okay. But I mean, the concept of care, I think, comes through in all of the pieces that I do. I think it drives a lot of you mean you hope to make a little bit of a difference in what you're doing. And I care very much about how people are perceived in the direction of society.
Thank you, Nina. Jun, do you want to say something about the notion of care?
So in my life, so this care is a great question, and I have several stories to tell, but then anyway, I have to be less organized a little bit. So so basically, a lot of scientists, like cell biologists, are culturing cells, right? You probably have heard of this very special cell line, cancer cell called HeLa, right? I'm sure most of you have heard about the story of HeLa. Basically, it is the first human cancer cells that can be kept alive outside of a human body. So, but then, so basically it's kept on a dish, and I've shown you images of these cells. In fact, in one of the movies I show in my first slide, it's actually a time-lapse microscopy video of HeLa cells, right? So basically, 99% of the people today culture HeLa cells on a flat plastic dish. But of course, this is a very, very poor approximation of a human body, right? So HeLa cell actually is a tumor from surface, right, of female. And it's a tumor, so it's kind of three-dimensional, right, living inside the human body. So you are forcing the cells to grow on a flat plastic surface. So, and why do you want to do that, right? And the reason is because we love to do it because it's flat, right? You can put on a microscope and you can see the cell divide. So we are forcing the cells to culture on this highly non-physiological condition just because human scientists like to see them divide, right? It is the is the only reason. And to me, this is really, really a crime. And the interesting thing is, if you look at history in kind of 1950s, when HeLa cell was first taken out of the body, the very first experiment, the scientists actually took care to grow the cells in 3D as if it is still in a tumor. But somehow, during this 50 years of cancer research, people have forgotten to do that because growing cells on a transparent dish, a glass, is so convenient, right? So, and then people originally grow the cells on a glass surface, And then somehow in the 70s, they switched to grow the cells on a plastic surface. That's simply because using glass in the lab is dangerous, right? You can cut your finger. So change to plastic. But then nobody have kind of discussed about the chemical, structure of the surface is different, right? So basically, the history of human cancer research is a history of convenient to the human scientist or the pharmaceutical company, but nobody is thinking about caring about how the cells feel. So once again, kind of the word care to me is about giving back the cells the body that is kind of that has been stripped from in the very beginning, and kind of is my mission of kind of figuring out how to what kind of body we should give back to the cells.
Great, great, June. If someone wants to ask questions, you can also turn on your microphones, guys. Right now it's fine. You can turn on your cameras and mics. You don't have to only do it through the chat box. You can all talk. I would like to bring up, there's a lot of good questions, but I will try to bring them all up in an order that makes more or less sense with what we're saying. There's another question that from Rowan Riley, and he says, the Medusa experiments are amazing. Do you think that are other ways to close the loop and provide any other body circumstances to the cells? You know, what would be other bodily circumstances that we can provide to the cells, let's say, besides these Medusa experiments?
Yeah, so this is a great question, and I hope I'm not boring you with too much technical bits, right? I'm a nerd, and I love these kind of technical things. So, but if you're not familiar with this field of research, you can go to YouTube and kind of search for the word decellularization. So a lot of scientists are now, what they're doing is they will take an organ, right? For example, a heart from a pig, and they will use chemical solutions to destroy all the cells, right? So basically destroy all the cells and remove all the cells, all the living part of the heart, leaving behind a shell, a ghost that still have the shape of the heart, but is completely stripped of all living cells and all the genes and basically all the cells, right? So what they find out is this shell, the ghost of a heart, you can actually put back cells. For example, cells, immortalized heart muscle cells, put back into the shell. And for some reason, these cells will behave as if it's finally going home, right? And in the YouTube videos, you can see that the heart, this ghost of the heart, after they got replenished, the cells are coming back to these shells, the heart will start beating, right? So basically, the cells will behave functionally like the cells in the heart, right? So basically, as if you can separate the body into the body, the form, and the soul, which is the cells, right? Like the form and the content of the body, and then you can actually combine them back into a living, beating heart. So we are very fascinated with this idea. This kind of decellularization has been around for about 15 years, but what we're trying to do is, can we make a sculpture, right, and made of completely inorganic material like a glass that kind of maintain the shell of the organ, but we somehow can perform everything like this decellularized organ, like a heart. So we can do that. In fact, there's something that we are doing in Melbourne, actually, with Monash University. We actually, it's kind of too much technical detail, but we can actually use a very, very small chisel so small that the point of the tip is the size of an atom. We can actually use that chisel to make a sculpture, right, that copies the tissues, right? So we can kind of use a microscope to take a kind of a detailed image of a real tissues. But now we no longer make a fossil. We will use a piece of plastic and use this chisel to kind of make a sculpture according to the body, right? And the cells will still respond, right? Without any proteins or any kind of biomolecules, as if the shape itself is important, as if the cells are not communicating by chemical kind of signals, but they're communicating by touch. So that's something I still think is our work, but I still, even I'm talking about it, I still think it's kind of really amazing, right? So yeah.
May I introduce another question? We have another question for Dr. Nina Sellars. And this question regards the idea of the tissue bank, where you found where you got your cells from. And this question asks about the source of bodies, or the body as a source, and the way that we use it. Like, what are the politics and the ethics? And there was something that June said about the hierarchical perceptions of life, which I think is also interesting. Like, how do we source our cells, and what are the politics and the ethics of tissue banks, and like the ownership, and also many times there's specifically these cells that come from female bodies. There was a question about it earlier. And how do we use the bodies, or female bodies, or specific bodies, as sources of cells, and who owns these cells, and what are the uses that we do of these cells outside of the body when we're working with them for different purposes?
Okay, it's a good question. So for me, accessing those cells, I went through a very safe, trusted route in a way, because I was just going through the same process that a scientist would. So the tissue bank, the ATCC, is just a standard place where you would be buying cells, and they're sort of anonymous. I could have found out, I guess, through testing whether they were male or female, but they just come to you as an anonymous, and you're paying for all the process and the procedure that they've been through. But prior to that, I did actually try, I was originally thinking of working with primary tissue, like my own tissue. And I did approach a plastic surgeon. I only wanted a small piece, but it was actually more problematic to try and access my own body, which I didn't seem to have a right to. I mean, actually, it's interesting, JJ Hastings, another art science person, has actually, I think, worked with Helen Pynor to show that you can have access to your body parts to use for artworks. But at the time when I approached the plastic surgeon, it was just a no deal. But he did offer me the fat from other people. It was easier to leave the surgery with primary tissue of other patients. So there's an interesting sort of discussion, because I thought that was stranger, that I couldn't access my own body. But the route that I finally chose, partly because I'd already made quite a complex work, was to go through a traditional standard, tried and tested route that scientists would use for getting tissue. So.
Great, thank you very much. I asked you this because recently at the TTT conference, they were talking about how certain cells are sourced, and they talked about your work exactly. So that's why I thought there was like a strong connection in the way that we think of the use and availability, as we cannot necessarily use the cells from our own body. So that's why I thought it was relevant that you told us a little bit about the story of your sourcing. I would like to bring up a question, but Gail Neon, he's an artist interested in bioart methodologies to evaluate embodiment of the materiality of the body. How do you see these methods can communicate to wider public a new dialogue of post-anatomy or more posthumanism as engagement with more complex research or ontological discussions in being and becoming? Do you consider the role of embodiment when relating information to the public?
I think I designed my works to be engaged on different levels. So at first, when you approach it, there's just the aesthetic engagement. then I hope that people will keep, I mean, I do a whole lot of research for my work. So if you keep on digging down, there's a logic that continues all the way down to develop further questions, hopefully initiates enough interest in the beginning for people to keep digging into this. I hope that people engage with the ideas. I don't always know how successful I am. I don't often think of like public engagement or a dissemination of an idea. Yeah, I also, probably a little unusual for an artist, I also write a lot at the same time as making the work. So I tend to treat the artworks as complementary to the text that I write. And like when I was working in the lab, my lab book was a mix of protocols and these notes, almost like an epistolary sort of discussion with the cells as I was working, that then developed into text. So there's levels of engagement for people to access the works. And I think it's an important part with the arts and sciences to emphasize, I don't think I could engage with the arts and sciences so well if I hadn't been introduced to writing through cultural studies, media theory sort of lines. So I was very influenced by writers Joanna Zielinska and Gary Hall, and this inquisitive way of walking people through an argument, and even for myself, being explorative through the writing. I think at art school, we tend to get very much taught, you know, to basically write what we're about to make or dissect it afterwards. But the cultural studies style of writing is exploratory, and it allows you to think and make at the same time. So yeah, so hopefully people can engage with my ideas through different avenues, and the embodiment of the artworks is important, but I think the text equally so. I hope that sort of answers.
It answers to me. Is something that you want to say about this, June?
So basically, I'm a scientist hiding in a lab, right? So my job is to do these things, and then as you know me really, really well, I have to either seriously think about a target or a aim, or pretend to tell my funding agencies that what we're doing is going to cure cancer or whatever, is going to make people live longer or make a lot of money, right? So that's kind of the academic environment that I'm in. If I told people that I went to see Nina's artwork, and then that inspired me to do this, to think about bodies and cells, then immediately kind of shut down, right? So in my lab, as you know, in CTU, you probably remember I have a bench for in my lab that I said is preserved for artists, right? So any artist will come into the lab, and then he or she will have the bench, right? And we even for a while, the people in my lab even decorated that bench as an art and science bench, but then my department, after they learned about it, they said that, oh, you have a bench for artists, which means that you don't need that bench, right? So can we take away that bench and give it to another professor? So basically, I think about public engagement, the situation is there's a, at least not for this audience, but for the public administrator funding agencies, they tend to think that science is going to make you live longer and make a lot of money, and art is for your is a hobby, right? It's kind of for your personal growth or inspiration. So basically, you can do art at night or in the weekends, but science is going to reach this kind of utopian view of kind of perfect life. So therefore, I think the work that I mentioned to you today, and also a lot of other fellow scientists that are inspired not by this kind of money making or this kind of aims, are very, very precious, because this is what keep scientific research or this spark of creativity alive. And in the 21st century, when science are becoming a business, that we really need artists to give us this energy, to give us an inspiration that is not from a usage and kind of practical point of view. So, and that's why platforms like these are very, very important. I'm sure future historians will say that in sometime in the 21st century, science was saved by artists. And the scientists just don't know yet, but they will learn. So yeah, that's
Thank you, June. That's beautiful. I think we're about to, sorry, can you say something?
No, I was just going to say that's incredibly generous. And I think in what you're saying and your lab, I think it's so valuable. And I think it's just so generous to have a space where there's an openness to exploring having artists in there. I know sometimes I find that doing the art side, you're seen as like the non-thinking addition to, I used to joke that I'm not very good at being wry and playful. Often people want you to come in and do something that's wry and playful or to advertise a certain thing. I'd love this idea of collaboration. And I think as I get older, where you're part of something that never would occur unless these entities came together. So it's something I wouldn't be doing separately, something the scientists wouldn't be doing separately. And I think that's where I'd like to see the arts and science collaborations go. So, I mean, what you're describing is, you know, something I would like to see happening more. And it's very generous of you. So thank you.
Thank you.
The bench is over there. That bench. I think Mauro used to work on that bench, right? But the bench is no longer there. That's really.
But the idea and the hope is, you know, so I think, yeah, this is what I love.
Yes. So if anyone in the audience has more questions, we're about to wrap up. We're about to finish. And I would like to mention Dolores' statement reminds us that Hege Tapio is working with the fat cells from her body, from her own body. And this TTT talk I was talking about presented White Feather Hunter's work. She's also working with cells from her own body. Isabella Burratti is also sourcing materials from the female body. So there's like other examples of like taking tissue from one's own body. So just this was Dolores, Dr. Dolores. Contribution to the conversation. You're muted, Dolores. If you want to say something, you can, please.
A question. I don't know how long it will take to answer, and I partially know the answers, but I think it would be interesting for the rest of the audience to be aware of this, since I know Nina well. I don't know Yun as much. I mean, as we have met only once in real life. What brought either one of you into this quote unquote other discipline? What was the impetus?
June, do you want to take this answer first?
I met Mauro, that's the answer. She was a PhD student of obviously from a different school and from a different, under different supervisor. But she kind of come to my lab and my courses and asked a lot of questions. And so before meeting Mauro, I was an arrogant scientist because I just don't speak the language of an artist. And when you don't speak the language, like I'm trying to, yesterday I was trying to listen to Mauro's talk in Spanish on YouTube. I kind of interesting experience. It's just like talking to artists because they are speaking in a totally different language. And a lot of scientists, my colleagues, and they're some of the smartest, most intelligent people that I've met, they didn't have time for artists because they're too busy, they're too clever, there are too many grants to apply for, too many papers to write, and there are never enough for them. there's never enough papers, never enough grants. They just want to get bigger and bigger and publish more and more papers. But then, as I said to you, to me, this is very, very problematic. Science today is totally about being famous and getting a lot of grants. And to get a lot of grants, you have to make promise on something, right? And these promises are kind of they are kind of unrealized dreams of human hopes, and they are kind of our fantasies. And increasingly, scientists are selling our practice, if you like, our work, to such impossible ideals that is impossible to realize. And this, we are kind of trapped into this cycle. And the more I talk tomorrow, the more I understand that artists and philosophers and writers, they are, because they are thinking in a different ways, they can provide energy to science that science is lacking now, about imagination, about not kind of basing totally on past evidence, and this kind of energy I really want to introduce to my colleagues. So as I mentioned, I'm never going to be an artist, right? So my job is to become almost like a connection between scientists and artists. So by kind of telling them that, well, work with this artist is going to be is going to transform your career and way of thinking. You can kind of publish better paper and get more grants if you more ideas for grants if you work with artists. And for some reason they understand this kind of language, right? They will say, oh, by working with the artist, I can get more grants, right? That's what all I want, right? So that's my this kind of the self appointed role that I'm kind of decided for myself. So I hope this is something. Yes, short answer is Mauro.
That's a beautiful answer, Mauro. For me, I can only say in hindsight, it didn't feel that way at the time, but because everything I do is connected to anatomy, I spent a lot of time in hospital when I was a teenager. And I was actually blind between the ages of 16 and 18. I had brain tumors and hydrocephalus, and I think visually I got obsessed with the body and with drawing. So I have a very traditional background. I'm a classical drawer and then photography as well. And I ended up spending a lot of time in the anthropology department and in life drawing. So it's been this organic progression that I can make sense of in reflection. I mean, I didn't even apply for the job as a preceptor. I was offered that job from my drawing, but yeah, I've just become obsessed with anatomy, and I've tried it on from all different views, from being a patient body with my anatomy connected to machines, to all the way through to body dissections, to anatomical illustration. And I'm just very much fascinated with how that concept of the body has filtered into society. And it's a very visual science, so it naturally connects the arts and sciences quite well.
Thank you, Nina. We have Jennifer Booth has been asking us a set of very interesting questions, and I would also like to bring her into the conversation. But she's an artist that's been working with her own body, and one of the questions that she's asking us is like, how can artists speak the language of scientists, like in order to understand each other, or where can we find the scientists that are interested in collaborating? Right. So she's working with cancer cells and with what's normal and abnormal female bodies when we have cancer cells. And like there's like a set of questions, but one interesting question is how do we find, and June was saying it, many scientists may not be interested in collaborating with artists, but where do we find those that are, right? And June recently shared a publication about from Nature saying that increasingly scientists are interested in collaborating with us. Do you have any suggestions for us, June or Nina, on how to find the scientists that might be able and willing to work with us and collaborate?
I'll let you answer, June.
So I'm going to tell you another story about Maro. So basically, a few years ago, I remember this. I can't remember. So basically, we were collaborating with my good friend. I think she's in the audience, Ali Wong, and artwork, right? So I was kind of providing kind of technical support for her artwork about DNA. Is really, really beautiful piece of work. So a lot of people, I engage a lot of my lab people. They went actually to the exhibition space and kind of participate in artwork. And a lot of scientists and engineers who are my friends said, Yun, what are you doing? How can you kind of waste your time with these people? So they came over to this exhibition, which is actually Art Basel, Hong Kong, right? And one of my friends who's an engineer, and she came over, and Maro, who was there, took us scientists and engineer and walk us through this Art Basel exhibition. And then afterwards, my engineer friend said that was the first time she went to an art exhibition, and she went there because she wanted to see why I waste my time there, right? So for her, is really, really just to see why I wasted my time. But by being able to kind of walk through the exhibition with an artist, art historian, artist, and she was kind of, she told me her mind was opened, right? So I guess you guys are artists, most of you are an artist, and you need to be patient too. Scientists are like children, and we are arrogant and we don't know what we're talking about. So you need to be patient with us. So one of the things we are trying to do in Hong Kong is, I really, really want to replicate this experience with Maro. So one of the things we're trying to do in Hong Kong is trying to get some scientists who are remotely interested in art to go to an art exhibition with us, like with some artists, and try to replicate this Maro factor. So basically, maybe going to see a contemporary art show for the first time is the beginning of something, right? So I think art science are still not quite young, right? So in history, human history is just a little bit, just a little moment, and please give us a few hundred of years, and maybe we can start to do something, right? So, but at this moment, I think the first step is to let scientists to become friends with some artists, so that they're no longer just a concept or just an image. So and please come to support Laser Hong Kong, right? So that's another way to doing that.
Do you have ideas, Nina, or where to find scientists? Otherwise, I can also add my grain of salt.
It's funny because I feel like after that I said go to bars where scientists hang out, but there is this social element. I mean, you have to enjoy working with the people. That's why it is very hard when it's a forced collaboration. The concepts and ideas. I mean, I feel fortunate working in anatomy. It already has this sort of natural crossover, and And I like your description of scientists purely because my brother is a quantum physicist, and I love to relay that to him. But yeah, it's, I think also being sincere and putting the effort into learning the language of the area that you're really interested in. People have dedicated their lives to the research that they're doing. So to make an approach with only maybe, you know, a year or two of interest can seem insincere. So yeah, I think patience and being a little bit of humility in the approach as well, and being willing to sit and listen, but then also stand your ground as well as an artist. You don't want to just be making publicity images for research, because in a way I don't think the scientists will get the benefit either. I mean, it's fantastic what June's done as well, that there has been something that's arisen separate. It's not just coming with ideas that want to be illustrated. I think that's the least interesting thing that can happen. So it's really interesting to hear what the take that June's had. So as an artist, don't get talked into to just being an illustrator. Be sincere and have a bit of humility in your approach, but then also bring something to it and have a bit of backbone in your work as well. So
great, Nina. Thank you so much. I completely agree with you. And I'm not one of the speakers, but Jennifer, I'm going to take the freedom to join in this answer. I think Nina is right. The first responsibility as artists is to learn more about a topic and to acknowledge that there's someone, as Nina says, has been devoting their life to it. So we have to approach necessarily with humility, but also knocking doors. Like I remember the first time I wrote an email to Dr. Lam, to June, and I was like, June, do you think we can, have lunch so I can talk to you about the things that I want to do? And in the beginning, he told me, I'm very busy, I'm sorry, But little by little, and with June and with other scientists in Mexico, I literally didn't know them, but I knew they were working on the field that I wanted to explore through art. And so I literally, wrote them an email. And when they gave me the chance, I lured them, into the beauty of the project that I was trying to convey and to work on. And sometimes what happens is that we change field very quickly. So one day I'm interested in the mitochondria, and the next I'm interested in cyanobacteria, and the next I'm working with plants. So we very readily move, let's say, between fields. And as Nina says, it's valuable that we learn to appreciate and devote the time that it takes to get to know the language of something specific. So we're approaching the end, and I would like to have Nina and June maybe give us some final thoughts. It can be, of course, in the notion of, I would love to end thinking about, of course, the medusa, how cells transform. I would love to think about fat as an organ. I used to think of fat as something extra as well, or like something non-living from our bodies. But looking into Nina's work, I learned very late in my life, I'm embarrassed to say, that it is actually tissue, that fat is not some like organic non-part of our body, but it is actually cells with a nucleus, with mitochondria, with like an actual cell of our body, which is conforms these tissues. And I only discovered it through your artwork. Somehow the cultural vision of fat is like something extra. So I would love to finish with any final thoughts that you may have, if they're regarding to fat as an organ or fat as a part of our body or something else. And also I would love to invite June, maybe you want to say something in which we can conclude today's laser.
Oh, wow. Maybe I'll link it to the notion of belonging. I think when I first started working with fat, I was thinking of how, when you think of how to make someone or have someone feel that they belong, it's a question of how to make them feel at home. And I think I was looking originally at fat, how to make it at home in anatomy. And I think through this work that I've been doing for the last few years, it's shown me that it's actually more valuable. I don't think fat's particularly interested at all at being at home in the body. And this idea that you were saying, that it actually is an instrument for maybe questioning anatomy. So that's with fat. I'm not sure I'm actually answering what you've presented, but yeah, just in addressing with the notion of belonging. I think questioning the value of belonging to anatomy is maybe becoming more contentious. So
I would like to respond to one of the questions because I've got a few minutes to think about in hopefully a better way, and that one is about speaking language of a scientist. How do you talk to scientists? And I also responded, I also saw some comments by clinicians, other words, and so basically many scientists are quite arrogant, right? Because they are, anyway, I think this basically human nature. But if you can think about the whole thing like a tree, so you can see the tree, the flowers, and the leaves, right? An artist or anyway, every field is like a tree, right? And we can only see and touch the flowers and leaves. And of course, when an artist approach a scientist, usually the artist would like to learn a little bit about the leaves and the flowers, right? But then the scientist will say, but you don't even speak the language. You don't know what is a chord, and you don't know what species anyway. So please go away, right? But then I think what we need to do, and also scientists also, when we're talking about the artists, we also have to remind ourselves that we're only looking at the leaves, and I think everybody have to think about there's some roots under the ground, and these roots are invisible, but they are the beginning of all the trees, all the flowers and leaves. So I remember Maro, when I first met her, another Maro story, right? When I first met her, she was telling me about posthumanism, right? Posthuman, but then I said, as scientist, I said, what are you talking about, right? I only see the leaves, and then when you said posthumanism, then I immediately think this is kind of, please don't waste my time, right? Please. But the more I learn about posthumanism, the more I simply chase down to the root, and the root is simply about, please don't look at things in a human-centric ways, right? But then in my research, I also have roots, and the roots is, if you want to study biology, if you keep thinking the cells like a human, we keep using languages like the cell sees something, right? The cell will, or basically, if you think about kind of biochemicals, A binds to B is like finding their way, then bind to each other, right? And then magic happens. But of course, the cells doesn't look like that, right? They don't have eyes, they don't see things, right? So to them, they are operating at a level that is unimaginable using human thoughts. So in a way, my roots is actually the same as Maro's root. It's just that we are using different languages or different flowers and leaves to describe this. So when you try and talk to a scientist, you may say that, oh, you're amazing, you work on CRISPR or you work on stem cells. I want to learn this, right? But this CRISPR or cloning or genomics are just the flowers and leaves, right? And of course, the scientist will say, please don't waste my time because it took me 25 years to develop these things. How can you make an artwork of my work in a week, right? That's impossible. But then I think everybody should respect our roots. And if we can trace down the roots, we're actually talking about the same things, right? Mm-hmm. So I think this kind of, the ability of trace down the roots needs some training. And in a way, artists are much stronger in this ability than scientists. Because all our lives, we are trying to describe the leaves and flowers. So, and in a way, maybe what we scientists need to learn more is to discover the roots. So I think, I hope this is clear, right?
I think this is a beautiful image to finish today. The idea of the roots of this common way of looking at the world, and how in the end we're all trying to find answers together, right? And there can be common. I think this is a beautiful image to finish today. And I'm very, very grateful to Dr. Nina Sellars for bringing us so many great ideas, so much inspiration. I think a lot of people, as you read in our chat, are very inspired, very happy. You've introduced us to things that we have never thought of before. So I'm very thankful. I'm very thankful to you, Dr. Lam, as well, for sharing your experience with working with artists, and also for sharing your experience working with cells and keeping them alive and talking about their becoming. So thanks everyone for joining. If you feel like it, please follow our Laser Hong Kong accounts to be informed of the next events that we will be hosting. And that is it. Thank you everyone for joining.
Good night.
Thank you. Bye-bye.
Have a nice Saturday. Bye-bye.
Bye-bye.
Beautiful.